The bow doors swing open. Salt water rushes onto the tank deck. A Sherman tank, 30 tons of steel and armor, guns its engine and drives straight out of the ship's belly onto the beach. No crane, no ramp, no dock. The ship is sitting on the sand with waves crashing against its hull, and tanks are rolling off like cars leaving a parking garage. It's June 6, 1944, Normandy, and the ship that just delivered that tank to the beach is designed to do something that every naval architect in 1940 said was impossible. It's designed to ram itself onto a beach at full speed, open its front like a giant mouth, unload 50 tanks in an hour, then back off the beach and float away to get more. The ship is 328 feet long, weighs 4,000 tons fully loaded, and it's basically a giant floating shoebox with a flat bottom and a front door. The British call it a self-destructing vessel because the stress of beaching should rip it apart. The Americans call it the LST landing ship tank, and it's about to change warfare forever. Before the LST, getting tanks onto a hostile beach was basically impossible. Ships carried tanks in their holds. Cranes lifted tanks out of the holds and lowered them into smaller boats. The smaller boats ferried the tanks to shore, where they had to find a pier or a dock to unload. If there was no pier, the tanks couldn't land. If the enemy destroyed the piers, the invasion stopped. The whole concept of amphibious warfare depended on capturing a port intact, which was nearly impossible because any competent defender would destroy the port before retreating. Military planners called it the port problem, and it had no solution. Every major amphibious invasion plan from the 1920s and 1930s included a phase where assault troops captured a port, engineers repaired the port, and then the heavy equipment could land days or weeks later. It was slow, vulnerable, and gave the enemy time to bring up reinforcements and counterattack. The LST solves the port problem by eliminating the need for a port. The ship carries tanks directly from the loading dock to the invasion beach. It drives right up onto the sand, opens its bow doors, drops a ramp, and the tanks drive off. The entire unloading process takes less than an hour. Then the ship backs off the beach, returns to the loading area, picks up more tanks, and does it again. One LST can make multiple trips per day. A fleet of LSTs can land an entire armored division on an undefended beach in 24 hours. This capability, landing heavy vehicles directly onto enemy beaches, is so revolutionary that it changes the entire strategic picture of World War II. Let's go back to 1940 and understand why the LST seemed impossible. Ships are designed to float, that's obvious. But they're specifically designed to float in deep water, with their hulls submerged and their keels well below the surface. The shape of a traditional ship hull is curved, with a rounded bottom that helps it cut through water efficiently. This design works great in the open ocean, but creates a problem when you try to beach the ship. If you drive a traditional ship onto a beach, the curved hull doesn't sit flat. The ship tilts to one side. Even worse, the keel, the spine of the ship running along the bottom, digs into the sand and gets stuck. The ship can't back off. It's permanently grounded. Naval architects call this a constructive total loss, which is a fancy way of saying the ship is worthless. So the obvious solution is to design a ship with a flat bottom, right? Just make the hull flat like a barge, and it'll sit on the beach without tilting or getting stuck. Simple. Except it's not simple at all, because a flat bottom creates a dozen new problems. First, a flat-bottomed ship is terrible in rough seas. It pounds against the waves instead of cutting through them, creating massive stress on the hull. Second, a flat bottom makes the ship unstable. It rolls side to side, in even moderate swells. Third, a flat bottom is inefficient. It creates drag, slowing the ship down and wasting fuel. Every traditional ship design includes a curved hull, because that's what works. Making the hull flat feels like going backward, abandoning centuries of naval architecture knowledge. But in 1940, Britain is desperate. The German army has conquered most of Europe. The British army evacuated from Dunkirk, but left all its heavy equipment behind. Churchill knows that eventually Britain will have to return to the continent. And that means amphibious invasions, and that means solving the port problem. The Royal Navy starts experimenting with shallow draft vessels that can beach themselves. They convert some existing ships, including 3 small tankers, by cutting off the bow and installing a ramp. The conversions work, sort of. The ships can beach and unload vehicles, but they're slow, unstable, and the converted bows leak constantly. The ships are also too small, carrying maybe 5 or 6 tanks at most. The Royal Navy concludes that converted vessels aren't the answer. They need a purpose-built ship designed from the ground up for beaching operations. The initial British design is called the Atlantic Tank Landing Craft, or TLC. It's supposed to be large enough to carry 40 tanks, fast enough to cross the English Channel in a few hours, and shallow enough to beach itself. But when engineers start working out the details, problems pile up. To carry 40 tanks, the ship needs to be huge, maybe 4,000 tons displacement. A ship that big with a flat bottom will be horribly unstable in anything but calm seas. The English Channel is rarely calm, winter storms are brutal, and even summer weather can be rough. A ship that capsizes in moderate seas is useless. The British tried various compromises: make the ship smaller, reduce the cargo capacity, add ballast tanks, use stabilizing fins. None of the solutions work well. The ship is either too small to be useful, too unstable to be safe, or too complex to build quickly. By late 1941, the British program is stalled. They have a concept, but no workable design. They need help, and they know where to get it. The United States has more shipbuilding capacity than the rest of the world combined. American shipyards are building Liberty ships at an incredible pace, sometimes launching a complete cargo ship in less than a week. If anyone can figure out how to mass-produce landing ships, it's the Americans. In November 1941, a British delegation travels to Washington to discuss the landing ship problem with their American counterparts. The British bring their designs and specifications. The Americans look at the plans and start asking questions. Why does the ship need to be so fast? Why does it need to carry 40 tanks? Why is the draft so shallow? The British explain their requirements, and the Americans push back on almost everything. Here's where the story gets interesting, because the American approach to the problem is completely different. The British are trying to design a ship that does everything perfectly: fast, stable, shallow draft, large capacity, all at once. The Americans realize that's impossible and start making the ship doesn't need to be fast. It just needs to be fast enough. It doesn't need to carry 40 tanks. 30 is fine. And maybe the draft doesn't need to be quite as shallow as the British want. These compromises unlocked the design. The lead American designer is a naval architect named John C. Niedermayer, working for the Bureau of Ships. Niedermayer has experience with shallow draft vessels, having designed some river barges and coastal freighters. He understands the structural challenges of flat-bottomed ships. He takes the British requirements, strips away everything that isn't absolutely essential, and starts sketching a design that might actually work. The key innovation is the bow door. Previous landing craft had ramps that lowered from the bow, but the bow itself was a solid structure. Niedermayer's design makes the entire bow open like a clamshell. Two large doors hinged at the sides swing out, and a ramp hinged at the top lowers down. This creates a wide opening, about 14 feet across, large enough to drive a tank through without precise maneuvering. The bow doors are watertight when closed, sealed with rubber gaskets, and held shut with heavy clips. When the ship beaches, the crew blows ballast tanks to settle the ship firmly on the sand, then opens the bow doors. Tanks drive up from the tank deck, across the ramp, and onto the beach. The tank deck itself is a wide open space running almost the entire length of the ship, about 250 feet long and 28 feet wide. There are no pillars or supports in the middle of this space because they'd block vehicle movement. The deck is a single, uninterrupted expanse of steel plating. Supporting this span without any internal pillars requires massive structural beams running along the sides of the ship. These beams are several feet deep, essentially forming the ribs of the ship's skeleton. The weight of all this structure is enormous, but it's necessary to keep the tank deck from collapsing when loaded with vehicles. Above the tank deck is the main deck, where smaller vehicles, supplies, and equipment are stored. Above that is the superstructure, where the crew lives and works. The design stacks everything vertically to minimize the ship's length and keep the center of gravity low. This helps with stability. A flat-bottom ship wants to roll side to side, but keeping the weight low fights that tendency. The propulsion system is also unconventional. Most ships use a single large propeller, or maybe two propellers for redundancy. The LST uses twin screws, but they're positioned in tunnels on either side of the hull. The tunnels are recessed into the bottom of the ship, protecting the propellers from damage when the ship beaches. This design means the propellers are always submerged, even in very shallow water, maintaining propulsion when a normal ship would have its props out of the water. The tunnels also direct water flow in a way that improves steering, important for a ship that needs to maneuver precisely when approaching a beach. Drop a comment if you've ever been on an LST or seen one at a museum. These ships are still around, rusting in harbors or converted to museums. The engines are diesel, not steam. This is a significant choice. Steam engines are more powerful and were standard for military ships in the 1940s. But diesel engines are more reliable, easier to maintain, and use less fuel. For a ship that might spend days sitting on a beach with its engines running, diesel makes sense. The LST uses two General Motors diesel engines, each producing 1,700 horsepower. That's not much for a 4,000-ton ship, which is why LSTs are slow. Top speed is about 11 knots, barely faster than a person can run. But speed isn't the point. Reliability is the point. The crew quarters are cramped. About 120 sailors operate the ship, and they're packed into small spaces. There are also accommodations for about 160 troops, the soldiers who will guard the tanks and fight once the landing happens. The troops sleep in racks stacked 3 or 4 high. There's a small galley, a medical bay, and not much else. The ship is designed to be functional, not comfortable. By early 1942, Niedermayer and his team have a complete design. They present it to the Navy, and the Navy approves it with some modifications. The official designation is LST Landing Ship Tank. The Navy orders the first batch of LSTs in March 1942. Contracts going to multiple shipyards across the United States. The goal is to build hundreds of these ships as fast as possible. D-Day is still more than 2 years away. But planners already know they'll need a massive fleet of landing ships to invade Europe. Building the first LST reveals just how challenging the design is. The flat bottom creates stress points that normal ships don't have. When the ship is loaded and floating, the weight of the cargo presses down, while the buoyancy of the water pushes up. The forces want to bend the ship like a bow. Naval architects call this hogging and sagging, and it's a constant problem for ships. The LST's flat bottom makes hogging and sagging worse, because there's no curved hull to distribute the forces. The structural beams along the sides have to be incredibly strong to resist bending. The bow doors are another challenge. They need to be watertight, but also need to open and close quickly. The hinges have to support the weight of the doors and the ramp, several tons of steel, while also allowing smooth movement. The rubber gaskets have to seal perfectly, even after being battered by waves and scraped on beaches. Engineers test and refine the door mechanism dozens of times before getting it right. The ballast system is critical. When the LST approaches a beach, it's riding high in the water with its propellers barely submerged. To beach properly, it needs to settle down onto the sand firmly. The crew floods ballast tanks built into the sides of the hull, adding thousands of tons of water. Weight. The ship sinks lower. The flat bottom presses onto the sand, and the ship is stable enough to unload without shifting. After unloading, the crew blows the ballast tanks with compressed air. The ship becomes lighter and more buoyant, and it can back off the beach and float away. Getting this ballast system right takes time. Too much ballast and the ship settles so deep it can't get off the beach. Too little and the ship doesn't settle firmly and shifts with the waves, making unloading dangerous. The final design uses a complex system of multiple tanks that can be filled or emptied independently, allowing the crew to fine-tune the ship's trim and balance. The first LST, designated LST-1, launches in September 1942. It immediately goes through sea trials. The Navy needs to know if this radical design actually works. They load the ship with tanks and trucks, take it out into the ocean, and put it through its paces. The ship is slow, as expected. It rolls heavily in even moderate swells, making everyone on board seasick. But it doesn't capsize. It doesn't break apart. It handles rough seas better than the British predicted, though worse than a traditional cargo ship. Then comes the beach test. They find a suitable beach on the Atlantic coast, drive LST-1 at full speed toward the sand, and watch what happens. The flat bottom hits the beach, and the ship rides up onto the sand, carried by its momentum. It stops with the bow high and dry. The crew floods the ballast tanks. The ship settles. The bow doors open. A Sherman tank drives out onto the beach. It works. It actually works. The Navy immediately orders more LSTs. Production ramps up at shipyards across the country. By the end of 1942, 20 LSTs are under construction. By mid-1943, that number reaches 100. By D-Day, in June 1944, over 1,000 LSTs have been built. It's one of the largest shipbuilding programs in history, producing more tonnage of landing ships than of battleships, cruisers, and destroyers combined. But building the ships is only half the challenge. The other half is learning how to use them. LSTs are unlike any military vessel that came before. Naval officers trained on cruisers and destroyers have no idea how to beach an LST and get it off again. The Navy establishes training schools where officers and crews practice beaching operations in safe conditions. They learn the procedures, the timing, the signals, all the coordination required to beach a ship, unload it, and get it off the beach without damage. They learn that beaching depends on the tide. The LST needs to beach at high tide so that when the tide goes out, the ship stays on the sand, with water deep enough around the stern to keep the propellers submerged. If they beach at low tide, the tide comes in and might lift the ship before unloading is complete. Or worse, turn it sideways and dump it on its side. Tides are critical, and crews have to study tide tables for every beach they plan to hit. They learn about sand types. Hard-packed sand is ideal. Soft sand can trap the ship. Rocks and reefs damage the flat bottom. Crews use sounding equipment to check the beach profile before committing to a landing. They look for a gentle slope, no obstructions, and a solid bottom. The best beaches for LST operations are relatively rare, which limits where amphibious invasions can happen. They learn about wind and waves. An LST sitting on a beach is vulnerable to weather. Strong winds can push the ship sideways. Large waves can lift the stern and smash it back down, potentially damaging the propellers or rudder. If the weather turns bad during unloading, the crew has to get the ship off the beach immediately, even if it means leaving some cargo behind. By early 1943, LSTs are ready for combat. The first large-scale use is Operation Husky. The invasion of Sicily in July 1943. Over 200 LSTs participate, landing thousands of vehicles directly onto Sicilian beaches. The operation is a massive success. Tanks reach the beaches within hours of the initial infantry assault. The Germans and Italians have no answer for this. They expect the Allies to capture a port first, giving them days or weeks to set up defensive lines. Instead, Allied armor is ashore in hours, racing inland before the defenders can react. The success in Sicily validates the LST concept. More importantly, it teaches the Allies lessons about how to use LSTs effectively. They learn about spacing the ships to avoid congestion on the beach. They learn about using Navy Beachmasters officers, who coordinate traffic and unloading schedules to prevent chaos. They learn about preloading vehicles in the correct sequence, so tanks that need to get off first are positioned near the bow doors. Sicily also reveals problems. LSTs are vulnerable to air attack while beached. German bombers damaged several LSTs during the Sicily landings. The ships carry anti-aircraft guns, but they're sitting ducks when stationary on a beach. The Navy develops tactics to minimize exposure, using smoke screens and timing landings for dawn or dusk when visibility is poor. The Italian campaign that follows Sicily uses LSTs extensively. Every time the Allies leapfrog up the Italian coast with an amphibious landing behind German lines, LSTs deliver the armor and heavy equipment. Salerno, Anzio, dozens of smaller landings. All of them depend on LSTs. The ships become workhorses of the Mediterranean theater. Meanwhile, in the Pacific, LSTs are revolutionizing the island-hopping campaign. The vast distances and lack of ports in the Pacific made amphibious invasions incredibly difficult before LSTs now. Marines can land on remote atolls with tanks and artillery. Overwhelming Japanese defenders who expected to face only light infantry. Tarawa, Saipan, Guam, the Philippines. Every major Pacific landing uses LSTs. The ultimate test comes on June 6, 1944. D-Day. The invasion of Normandy requires landing an entire army on French beaches. The operation uses every LST the Allies can muster. Over 200 ships. They're loaded in English ports with tanks, trucks, artillery, jeeps, bulldozers, every kind of vehicle the army needs. The LST fleet crosses the English Channel in darkness, arriving off the French coast at dawn. The beach called Omaha sees the heaviest fighting, but the beach called Utah is where LSTs shine. The first LSTs beach at Utah, 90 minutes after the initial infantry assault. Bow doors open. Shermans roll off onto French soil. Within hours, hundreds of vehicles are ashore. By the end of D-Day, the beachhead at Utah is secure and full of armor, all delivered by LSTs that drove right up onto the sand. The days after D-Day show the full value of the LST. The invasion doesn't end on June 6th. It's just the beginning. Every day, more troops and equipment need to come ashore. The Allies haven't captured a port yet. Cherbourg won't fall for weeks. Without LSTs, the invasion would stall. But LSTs keep running like a conveyor belt. They load in England, cross the Channel, beach in France, unload, return to England, and do it again. Some LSTs make the round trip twice a day. The volume of supplies and equipment they deliver is staggering. German forces try to counterattack the Normandy beachhead, but they can't concentrate enough armor to push the Allies back into the sea. Allied tanks, delivered by LSTs, outnumber German tanks. Allied artillery pounds German positions. The Luftwaffe, what's left of it, can't stop the LST convoys, because Allied fighters control the skies. The Germans are fighting a defensive battle they can't win, because the Allies solved the logistics problem. But LSTs aren't invincible. They're vulnerable to mines, torpedoes, and air attack. Several LSTs hit mines off Normandy and sink. Others are damaged by German coastal guns. One LST takes a direct hit from a bomber and explodes, killing most of the crew and destroying the cargo of ammunition it was carrying. The loss rate is significant, but the Allies build LSTs faster than they lose them. Shipyards back in America are launching a new LST every few days. The production pipeline is so robust that losses barely affect operations. The design of the LST also reveals some weaknesses under combat conditions. The flat bottom, while necessary for beaching, makes the ship a poor gun platform. The LSTs carry defensive armament, typically one 3-inch gun on the bow and several anti-aircraft guns. But firing these weapons makes the whole ship shake. Accuracy is terrible. LST crews learn quickly that their best defense is speed and maneuver, not their guns. They rely on escort destroyers and fighters for protection. The bow doors, while revolutionary, are also a vulnerability. If the doors are damaged, the ship can't unload. If the seals fail, the ship takes on water and might sink. Crews practiced emergency procedures for dealing with damaged bow doors, including using pumps to keep water out of the tank deck and makeshift repairs with welding equipment and steel plates. Some LSTs limp back to port with damaged bows, held together by cables and prayers. The living conditions aboard LSTs are miserable. The ships are cramped, hot, and noisy. The diesel engines vibrate constantly. The flat bottom means the ship rolls heavily in rough seas, making almost everyone seasick. Fresh water is rationed because the ships have limited tankage. Food is basic, canned rations heated in the galley. There are no showers, just buckets of cold seawater. Crews sleep in shifts because there aren't enough bunks. Morale is maintained by the knowledge that the work matters and by the camaraderie of shared hardship. The troops carried on. LSTs have it even worse. They're packed into the tank deck and the troop compartments with no room to move. In rough seas, with the ship rolling, vomit is everywhere. The smell is unbearable. Some crossings take days, and by the time the troops land, they're exhausted and sick. Officers learn to schedule landings, so troops have time to recover before going into combat. But that's not always possible. Despite the hardships, LST crews develop pride in their ships. They call themselves the large slow targets because the official designation LST is too boring. They paint names and nose art on their ships. They compete with other LST crews to see who can beach faster or unload more cargo in a day. The Navy doesn't officially encourage this, but they don't stop it either. Morale matters, especially for ships doing dangerous, unglamorous work. The LST's role expands beyond just landing tanks. Crews discover that the ships can carry almost anything. They load LSTs with supplies, ammunition, fuel, medical equipment, even entire field hospitals. They use LSTs to evacuate wounded soldiers from beachheads back to hospitals in England. They convert some LSTs into repair ships, with workshops on the tank deck where mechanics can fix damaged vehicles. The versatility of the LST makes it invaluable. In the Pacific theater, LSTs face different challenges than in Europe. The distances are much greater. Some crossings take weeks, not hours. The ships have to be self-sufficient, carrying extra fuel and supplies. The tropical heat makes the cramped interiors even more unbearable. Rust is a constant battle because the salt air and humidity corrode everything. Pacific beaches are often coral reefs, not sand. Coral is hard and sharp, damaging the flat bottoms of LSTs. Crews learn to approach coral reefs carefully, feeling their way with the bow to find the best spot to beach. Sometimes they use explosives to blast a channel through the reef before beach. The Navy develops specialized equipment, inflatable rafts and pontoon causeway sections, to help get vehicles from LSTs across coral reefs to the shore. Tides in the Pacific are extreme in some areas. The tide might rise or fall 15 feet or more, dramatically changing the beach profile. An LST beached at high tide might find itself sitting high and dry when the tide goes out, completely out of the water. The crew has to wait hours for the next high tide to float off. During this time, the ship is completely vulnerable. Japanese artillery or aircraft can hit it at will. Crews hate being caught by the tide, but sometimes it's unavoidable. The island-hopping strategy in the Pacific depends entirely on LSTs. Each island, the Marines assault, has no port facilities. LSTs provide the only way to get heavy equipment ashore. At Iwo Jima, LSTs land tanks and artillery under intense Japanese fire. The volcanic sand of Iwo Jima is soft and vehicles sink but the LSTs keep delivering equipment. At Okinawa, hundreds of LSTs support the invasion, running a constant shuttle of supplies and reinforcements. As the war progresses, the Allies develop tactics specifically designed around LST capabilities. One tactic is the shore-to-shore operation. Instead of loading LSTs at a distant port and sailing them to the invasion beach, they load them at a captured beach and sail them to the next invasion target. This reduces travel time and allows LSTs to be used more efficiently. In the Philippines campaign, LSTs leapfrogged from island to island, never returning to a distant base. Another tactic is the administrative landing. After the initial assault secures a beachhead, LSTs bring in the follow-on waves without opposition. These administrative landings are less dramatic than assault landings, but more important in the long run. They deliver the engineers, supplies, and equipment needed to build airfields, roads, and bases. The Marines take the beach. The Army, arriving on LSTs, builds the infrastructure. LSTs also participate in some of the war's most dramatic moments. During the Battle of the Bulge in December 1944, when German forces break through in the Odd, LSTs rush reinforcements across the English Channel to French ports. Then trucks haul the troops to the front. The speed of this response, made possible by LST logistics, helps contain the German offensive. In the Pacific, during the invasion of the Philippines, LSTs land troops directly into Leyte Gulf. Japanese kamikaze aircraft attack the invasion fleet, and several LSTs are hit. One LST, loaded with ammunition, is hit by a kamikaze and explodes with such force that nearby ships are damaged by the blast. The crew and all the troops aboard are killed instantly. Survivors from other LSTs describe the explosion as the largest they saw during the entire war. But most LST operations are routine, almost boring. Cross the ocean, beach, unload, back off, return, repeat. Thousands of these trips happen, each one mundane, each one essential. The unglamorous logistics work of LSTs is what makes the dramatic battles possible. By 1945, LSTs are landing troops in Germany itself. The crossing of the Rhine uses LSTs to ferry armor across the river once engineers build pontoon bridges. The final push into Germany would be impossible without the logistical support LSTs provide. When Germany surrenders in May 1945, LSTs are everywhere in Europe, delivering supplies to occupation forces. In the Pacific, LSTs prepare for the invasion of Japan. Operation Downfall, the planned invasion of the Japanese home islands, is the largest amphibious operation ever conceived. Thousands of LSTs are assigned to land the invasion force. The invasion never happens because Japan surrenders after the atomic bombs. But the fact that the Allies could even plan such an operation shows how much LSTs changed amphibious warfare. After Japan surrenders, LSTs have one more role. They repatriate troops, carrying soldiers from Pacific Islands back to major ports where they can board ships for home. They carry occupation forces into Japan. They ferry supplies to support the occupation. The workhorses of the war keep working in peace. By the time production ends in 1945, over 1,050 LSTs have been built. They represent a staggering investment of resources, materials, and labor. But the return on that investment is incalculable. Without LSTs, D-Day might have failed. Without LSTs, the Pacific campaign would have taken years longer. The ship that seemed impossible in 1940 became indispensable by 1944. The story of the LST is also a story of industrial capacity. Building over 1,000 large ships in 3 years is a feat that only American industry could accomplish. Shipyards that had built cargo ships and tankers switched to LSTs. Workers who had never built a warship before learned the specialized skills needed. The production line approach, breaking construction into standardized steps that could be repeated efficiently, was applied to LSTs just as it was to Liberty ships and destroyers. Some shipyards specialized in LSTs. The Dravo Corporation in Pittsburgh built LSTs on rivers, then sailed them down the Mississippi to the Gulf of Mexico. The Chicago Bridge and Iron Company built LSTs on the Great Lakes, then sailed them through the St. Lawrence Seaway to the Atlantic. Shipyards on the West Coast, the East Coast, and the Gulf Coast all built LSTs. The geographic distribution of production meant that even if one yard was bombed or suffered delays, others could pick up the slack. The standardization of LST construction meant that parts and equipment were interchangeable. An engine built for one LST could be installed in any LST. Bow doors built in one yard fit LSTs built in another yard. This standardization made repairs easier and faster. When an LST was damaged, repair crews could cannibalize parts from other LSTs or order standardized replacements from supply depots. The people who built LSTs were as diverse as America itself. Men and women, young and old, from every background, worked in the shipyards. Many had never worked in heavy industry before. They were farmers, teachers, shopkeepers, who took jobs in shipyards because the war needed ships. The training programs were intense but brief. Workers learned the basics of welding, riveting, pipe fitting, whatever skills they needed, then went to work. The quality of their work improved with experience, but even early LSTs were functional and reliable. There's a human dimension to the LST story that often gets overlooked. The young sailors who crewed these ships were mostly in their late teens and early 20s. Many had never been to sea before joining the Navy. They came from farms in Iowa, factories in Detroit, small towns across America. The Navy trained them quickly because the war needed crews. They learned on the job, making mistakes, learning from those mistakes, becoming competent sailors through experience. The officers commanding LSTs were often newly commissioned ensigns, young men barely older than the sailors they led. They had a few months of training, and then they were given command of a 4,000-ton ship with 100 men under them. The responsibility was enormous. Some rose to it. Others struggled, but most did their jobs well enough. And that was all the Navy asked. LST crews developed their own culture. They weren't part of the glamorous Navy, the battleships and aircraft carriers that got the headlines. They were the merchant marine in uniform, hauling cargo, doing unglamorous but essential work. They took pride in that. They knew that without them, the invasions wouldn't happen. That knowledge sustained them through the boredom, the discomfort, and the danger. After the war, the LST story doesn't end. The Navy keeps many LSTs in service for years. Some are converted for different roles. LST become repair ships, headquarters ships, even floating barracks. Some are sold or given to allied navies. Britain, France, Greece, Taiwan, South Korea, Japan. Many countries operate LSTs for decades after World War II. The Korean War sees LSTs back in action, landing Marines at Incheon in 1950. The Vietnam War uses LSTs for river operations and coastal landings. The Gulf War in 1991 uses modernized LSTs. Even today, variations of the LST concept remain in service with navies around the world. The basic design principles of the LST, the flat bottom, the bow doors, the ability to beach and unload directly, influenced all subsequent amphibious ship designs. Modern landing ships are much more sophisticated, with better engines, electronics, and weapons. But the core concept is still the LST. The US Navy's modern LST and LPD-class ships are direct descendants of the World War II LST. LST's influence extends beyond military operations into civilian uses that nobody predicted during the war. After 1945, hundreds of surplus LSTs sit in reserve fleets, anchored in rivers and harbors, waiting for the next war. But many never see military service again. Instead, they're sold to commercial operators, who recognize that a ship designed to beach itself and unload cargo has civilian applications. Ferry operators buy LSTs and convert them into vehicle ferries. The bow doors that once unloaded tanks now unload cars and trucks. Routes that previously required conventional ferries with side-loading ramps now use converted LSTs that drive straight onto beaches. Remote islands in Alaska, the Philippines, and Indonesia get regular ferry service using LSTs. The ships connect communities that lack proper docks or harbor facilities. Construction companies buy LSTs and use them as floating bases for building projects. A construction LST beaches at a remote site, opens its bow doors, and becomes a supply depot and workshop. Bulldozers and excavators drive on and off. Materials are stored on the tank deck. Workers sleep in the crew quarters. When the project finishes, the LST moves to the next site. This approach is cheaper than building temporary facilities on land and then abandoning them. Logging companies in the Pacific Northwest use LSTs to transport timber from remote coastal areas. The ships beach at logging sites, load huge logs directly onto the tank deck, then transport them to sawmills. Traditional cargo ships require docks and cranes to load logs. LSTs eliminate that infrastructure requirement, opening up logging operations in areas that were previously inaccessible. Oil companies exploring remote regions use LSTs as support vessels. The ships carry drilling equipment, supplies, and crew to coastal sites that lack ports. An LST can beach, stay for weeks or months, supporting operations, then leave when the exploration is complete. The self-sufficient nature of the LST, with its own power generation and water supplies, makes it ideal for remote operations. The Greek shipping industry becomes a major operator of surplus LSTs. Greek companies buy dozens of LSTs and convert them for commercial cargo service, particularly in island trade. The Aegean Sea has hundreds of islands, many without proper harbor facilities. LSTs solve the logistics problem by beaching directly. For decades after the war, converted LSTs are a common sight in Greek waters. Their flat bows pressed against Mediterranean beaches. Some LSTs are converted into floating casinos, restaurants, and even hotels. The large open tank deck provides space for gaming tables or dining areas. The upper decks have rooms with views. Entrepreneurs in various countries see commercial potential in the unusual layout and robust construction. Not all these ventures succeed, but some converted LSTs operate profitably for years. The scientific community finds uses for LSTs too. Research expeditions to remote areas use LSTs as floating laboratories. The ships beach near study sites, and scientists use the tank deck as workspace. Marine biologists studying coastal ecosystems use LSTs to transport equipment and set up temporary research stations. Archaeologists excavating coastal ruins use LSTs as bases, beaching the ships near dig sites and living aboard during the excavation season. Disaster relief organizations recognize that LSTs are perfect for emergency response. When hurricanes, tsunamis, or earthquakes destroy coastal infrastructure, conventional cargo ships can't deliver aid because the ports are damaged or destroyed. LSTs beach directly and unload supplies without needing docks. Several countries keep LSTs in their emergency response fleets, specifically for disaster relief. After the 2004 Indian Ocean tsunami, several old LSTs were pressed into service, delivering aid to devastated coastal communities. The U.S. Navy keeps some LSTs active for decades. The last LST built during World War II, LST-1156, doesn't retire until 1973, almost 30 years after the war ends. Some LSTs serve in the Navy for over 50 years, a testament to their robust construction. The ships that engineers thought might self-destruct from the stress of beaching proved to be remarkably durable. The design compromises that made LSTs possible also made them adaptable. Because they weren't optimized for any single purpose, they could be modified for many purposes. The flat bottom that makes them poor ocean vessels makes them excellent for river operations. The bow doors that were revolutionary in 1942 remain practical decades later. The simple diesel engines that made them slow and unglamorous also made them reliable and easy to maintain. Museums around the world preserve LSTs as monuments to the industrial achievement they represent. LST-325, built in 1942, serves through World War II, Korea, and Vietnam. After retirement, it sits in a Greek shipyard for decades. In 2000, a group of veterans and enthusiasts decide to save it. They sail LST-325 from Greece to the United States, a journey that takes months. The ship, nearly 60 years old, makes the crossing under its own power. Today it operates as a museum ship, one of the few LSTs still capable of beaching operations. Thousands of people tour it every year, walking through the tank deck where Sherman tanks once waited, climbing to the bridge where young ensigns once commanded operations. Other LSTs sit in museum berths around the country. LST-393 in Muskegon, Michigan. LST-510 in California. Each one tells the same story. The story of a ship that seemed impossible but became indispensable. The flat gray hulls with their odd proportions don't look impressive until someone explains what they accomplished. Then the story comes alive. The beaches, the tanks rolling off, the crews who served aboard these unglamorous vessels, doing work that mattered more than any battle. The legacy of the LST extends into modern military thinking about logistics and amphibious warfare. Before LST's amphibious invasions required capturing ports. After LST's invasions could happen anywhere the geography permitted. This changed strategic planning fundamentally. Defenders could no longer protect their territory by fortifying ports and leaving coastlines lightly defended. Any beach became a potential invasion site. This forced defenders to spread their forces thin, or risk being outflanked by seaborne landings. Modern amphibious doctrine still reflects LST-era thinking. Today's amphibious ships are more sophisticated, with helicopters and hovercraft extending their reach beyond the beach, but the core principle remains. The ship delivers heavy equipment directly to the operational area without requiring port infrastructure. This capability, pioneered by the LST, gives naval forces flexibility that land-based forces lack. The engineering lessons from the LST program influenced post-war design thinking across many fields. The LST proved that radical design compromises could work if they served a clear purpose. The LST wasn't trying to be a perfect ship. It was trying to solve one specific problem: landing tanks on beaches. By focusing ruthlessly on that goal and accepting trade-offs in other areas, the designers created something revolutionary. This approach, defining a clear problem and designing a solution specifically for that problem, even if it means rejecting conventional wisdom, became influential in military procurement and beyond. The LST showed that sometimes the best solution is the one that looks strange, performs poorly in traditional metrics, but excels at its intended mission. The people who designed, built, and crewed LSTs have mostly passed away now. John Niedermayer, the lead designer, lived to see LSTs influence amphibious warfare for decades. The shipyard workers who welded LST hulls and installed engines moved on to peacetime careers, taking with them skills and experiences from the war years. The sailors who crewed LSTs became veterans, telling their grandchildren about crossing the English Channel on a ship that looked like a floating shoebox. But the ships themselves endure, both physically in museums and conceptually in naval architecture. Every modern landing ship owes something to the LST. Every time a military needs to deliver heavy equipment to a shore without port facilities, someone thinks about LSTs. The solution that seemed impossible in 1940 became the standard approach by 1944 and remains relevant 80 years later. Looking back, the LST represents a particular moment in history when industrial capacity, engineering innovation, and military necessity combined to create something unprecedented. The United States in World War II had the resources and the industrial base to build over 1,000 large ships of a radical new design in less than 4 years. Few nations in history could have done that. The LST program worked because American shipyards had the capacity, American factories could produce the components, and American logistics could distribute the ships where they were needed. The LST also represents the contributions of ordinary people doing extraordinary things. The sailors who crewed these ships weren't elite forces. They were regular kids who joined the Navy, got assigned to an LST, and did their jobs. The workers who built LSTs weren't master craftsmen. They were ordinary people who learned shipbuilding skills during the war and applied them day after day in shipyards across the country. The collective effort of thousands of unremarkable individuals created something remarkable. The final LST built for the U.S. Navy was USS Washoe County, commissioned in 1971. By then, LST design had evolved significantly from the World War II original. Newer LSTs were larger, faster, better armed, but the fundamental concept remained. Flat bottom, bow doors, beach the ship, unload, back off. The principles that John Niedermayer sketched in 1941 still worked in 1971. Today, number LSTs remain in U.S. Navy service. They've been replaced by more modern amphibious ships, but other navies still operate LST-type vessels. The design is too useful to abandon completely. Any nation that needs to project power across water without relying on ports will eventually arrive at something like the LST. The engineering logic is too compelling. The beach is quiet now. The bow doors have opened for the last time on most LSTs, except for museum demonstrations. But in harbors and bays around the world, old LSTs sit at anchor or tied to docks. Their flat gray hulls rusting, their bow doors sealed shut. They sit waiting. Veterans of a war fought 80 years ago. Monuments to the moment when engineers figured out how to drive tanks off ships onto beaches, and in doing so changed warfare forever. The LST solved a problem that seemed impossible. Ships weren't supposed to beach themselves. Naval architects knew that. Centuries of shipbuilding tradition said it couldn't be done. But in 1941, when Britain was desperate and America was mobilizing, a naval architect looked at the problem differently. He accepted that the solution would be strange, slow, uncomfortable, and unconventional. He designed a ship that broke every rule of naval architecture, but did exactly what was needed. That ship, that odd flat-bottomed vessel with doors on its face, became one of the most important weapons the Allies had. Not because it was elegant or powerful or impressive, because it worked. Because it solved a problem. Because it let tanks drive straight onto beaches. And that capability changed the war. June 6, 1944. Normandy. The bow doors swing open. Saltwater rushes onto the tank deck. A Sherman tank guns its engine and drives straight out onto the beach. No crane. No dock. No impossible logistics. Just a ship designed to do one thing, and doing it perfectly. That's the story of the LST. That's the story of how engineers made the impossible possible by refusing to accept that it was impossible. Subscribe for more stories about the engineering that won World War